In the last few videos, we've talked a bunch about security, and in this video, we're going to take a lot of those concepts and combine them together to create a simple weather application. So to get started, I just have the starting code here. You can download this yourself in the description down below. It is linked, and you're going to get an application that looks like this on the side. Kind of ugly with the blur, but we can remove that blur with this class here on our body. If we just remove that blurred class, you'll see that it gives us a non-blurred version. And that blurring is just going to be there so that when we're loading the application, we can have it blurred out so the user knows we're loading. And once it's done loading, we remove that blur. As you can see, we just have a bunch of placeholder information for weather. We have a high, low, a feels like high, feels like low, wind, precipitation, daily weather for the next 7 days, as well as information hourly for everything that's going on in this particular location. So this is pretty common weather app information. And in order to get all of this information, we're going to be using an API called the Weather API. It's the Open Weather API at openweathermap.org/API. All you need to do is just sign up for an account and you'll get an API key that you can use for this application. And this is an API key that you want to keep private because it's something that if you were to enter your credit card and use this in a serious application where you're paying for it and using it a ton, if someone stole that, it could use your own credit card to pay for those different points. So again, it's something you need to keep secret, which we're going to do in this video. As you can see, there's a bunch of different API endpoints. We're going to be using the one call API, which gives you essentially all the information you need to build a generic weather app implementation. So if we just open the API docs, you can see here we make the API call by calling to this endpoint. We pass it in a latitude, longitude, anything we want to exclude, and the API ID, and it's going to give us all the information we need. We can also specify the units we want, metric or imperial, as well as a language if we want to do some kind of translations for these values. Also, something that I've done, in case this API changes in the future or shuts down or whatever, I've also included an example JSON file. This is the exact output that you're going to get from this API based on the calls that we specify. So if for some reason this API is shut down or you can't access it or whatever, you can use this example JSON file instead, and it's going to have all the information. Obviously, it's not going to allow you to change your location because it's just specified as London right now. That's the location that it's specified at, but it at least allows you to follow along with this application using this placeholder data if for some reason this doesn't work for you. So back to our actual code, what I want to do is first create a client and a server folder. So we're going to have a client folder for all of our client code. We'll just move that inside of there. And we're also going to have a server folder for all of the server code, which we don't have any of right now. We'll just move that example file in there. And the reason I'm doing this is because, like I said, we have an API key we need to keep private. We can't put it in the front end because it's public. We can't put it in our GitHub anywhere. We need to put it inside of our server. So that way it's not accessible by anyone except for us. And again, we'll need to make sure we put it in that env file so that we can make sure it's not pushed into our GitHub repository or anything like that. Also, in order to make API requests a little easier, we're going to be using Axios. So I'm just going to quickly cd into that client folder. And what I want to do is I want to initialize a package.json, npm init-y. I'm going to install Axios to make our request a little bit easier. And then I'm also going to install Parcel as a dev dependency. So we'll get the Parcel bundler in here, and I'll come back with you once this finishes installing. So that all just finished installing, we can go to our package.json here. We can set up our start script. We're just going to run parcel index.html. There we go. We can even remove this test script as we don't really need it. And you can see we have Parcel and Axios inside of here, which is exactly what we want. Now we can create a simple script.js file. And inside of here, we can just make sure we require that script.js file. And we'll make sure that it is deferred. Now, the very first thing I'm going to want to do inside of our script.js is actually make sure we can get the user's location. So first of all, let's just start up our application. We'll just run npm start. That'll start up our application on port 1234. And of course, we're getting an error. And of course, invalid version. That's just because Parcel version 1.2.4 has a little bit of a bug. I'm just going to downgrade to 1.123, reinstall everything, and then hopefully that'll fix the issue, and I'll come back to you when that's done. Okay, that just finished. Let's just run the start command again, and that should hopefully fix our issue because now the bug is no longer there. Again, just kind of an annoyance with Parcel. We refresh our page. We now have our application rendering, and we can go through it just like normal. We can close out this old version of our application. And like I was saying, the first thing we need to do is get the user's location. If we just inspect the page real quick, click on these triple dots and go down to more tools, you'll see a section called sensors. This allows you to actually fake your location. You can set no override and it won't do any overrides. Or we can say, you know what, we're going to fake that we're in London, for example. That's what I'm going to do. I'm going to say fake that I'm in London. So now when I get my location, it should be London latitude and longitudes. So in our script here, to get the user's location, just call navigator.geolocation. And you just want to call the get current position function. And this takes two callbacks. The first one is a success. So we're just going to call position success. And the second one is an error. So we're going to call a function called position error. So let's create those functions. We have position error, and we're going to have a function called position success. And in this error function, I just want to make a really simple alert that just says there was an error getting your location. Please allow us to use your location and refresh the page. Essentially, if the user denied access to their location, for up here, for example, they just clicked block, and then they just need to refresh their page after they click allow, and it'll allow them to actually get their location. As you can see, it even says reload the page. Okay, so that's going to be our load for an error. And in the case of a success, this is going to pass into us an object that has a coordinates property on it. So we can just say chords here. But in order to see this actual project, let's just do a quick console.log of this to see all the information we get returned. If we just inspect this here, you can see we're faking our location as London. So we should get latitude of 51 and essentially longitude of 0. We go to our console and we look in this chords property, you can see we get that latitude and longitude, which is exactly the same as the latitude and longitude that we're faking down here, saying that we're in London. And we could change this to say, you know what, now we're going to say we're in Moscow. So if we refresh our page, our now coordinates are going to be in Moscow. Instead, you can see we have latitude 55, longitude 37, which is what Moscow is. In our case, we're just going to deal with London though. So let's just clear that out. Make sure we refresh here. And as you can see, we essentially need to get this chords property because we care about the latitude and longitude. Because if you remember, our API call needs a latitude and a longitude. So let's come in here. Let's just convert this E value, destructure it to just the coordinates property. And we're going to call a function, which is just called getWeather. And we're going to pass this in our latitude and longitude. So we can say chords.latitude, and we can say chords.longitude. This is going to be our latitude, longitude values. And then we have that function called getWeather, which takes in a latitude and a longitude. And instead of calling them latitude, longitude, I'm just going to abbreviate them to lat and lon, just a little bit easier to work with. And then this is where Axios is going to come in handy. So up here, I'm going to import Axios from Axios. Now we could just come down here and say axios.get, since we want to make a GET request and we want to request this URL. For now, we're going to just do this in the browser, but like I said, we're passing the API key in here, so we need to make sure we do this from the server eventually, so our API key is hidden. So we can just say app.get, paste in that URL, make sure that it's all on one line, and essentially we just need to replace these values. So we're just going to do some string interpolation here to replace these values, and we need to replace our lat, which is going to be our lat variable. Lon is the lon variable. Exclude, we can put in whatever we want here. For now, we're just not going to exclude anything. And then for our app ID, this is just going to be our API key. So to get our API key, what we need to do is just come over here. Once you've created an account, you can go to your account, which mine is Web Dev Simplified. This will bring up your API keys here. You can just copy the API key that you need, paste it in here, and we're just going to make sure that that's a string. And there we go. Now we've put all the information we need inside of this GET request. We can just say .den, and that's going to have our response. And for now, we can just console.log response.data. This should hopefully get us our information. We click save. Let's just go over here and inspect our page to see if this worked. In the console, we're of course getting tons of errors. These errors are actually really nice. Essentially, this site is blocking us from making these requests because we're making them from the client side, which means we're exposing our API key, and these should only ever be made from the server. So it's essentially blocking it, telling us that's the issue for the most part. So what we need to do is convert this to be on our server. So what we need to do inside of our server is create a new file called server.js where we're going to run our server. And I want to create another console here where I can just cd into that server folder and set up npm. So we'll npm init-y. And to create a server in Node.js the easy way, we're going to use a library called express. So npm i express, that's a pretty quick download there. And then we'll just do npm i-save dev nodemon. And nodemon is just a simple function that allows us to automatically refresh our server every time we make changes, kind of like how live server works or Parsel. This works exactly the same. So in our package JSON, we'll create a dev start script, and this dev start script is going to call nodemon with our server.js file. So every time our server.js changes, nodemon is going to refresh our server automatically for us. So now inside of our server, we need to set up a simple express server. Well, we can get that express library from require express. And then the nice thing is, in order to get an application, we just say app is equal to calling the express function. So we just take express and call it as a function. That'll give us our application. And this app is where we define everything. So we can say app.listen. and we define what port we want to listen on. In our case, we're going to use port 3001. So we're going to say our application for our server is running on port 3001, and we're going to say app.get/weather. So anytime we go to localhost 3001/weather, that's going to call this function right here, and it's going to take in a request and a response. The request is essentially all the information from the client, and the response is everything that we actually send down to the client. So we can get things such as the URL parameters from the request. So we can get the latitude and longitude, which come from our request as just saying request.query. They're coming from the query of our request. But in order to access our query, we need to tell our app to do that. So we can say app.use express.url encoded, and we can set extended equal to true. All this does right here is it essentially says, okay, we're going to be accepting query parameters from the URL, and we need to be able to parse those from request.query. And that'll get us our latitude and our longitude. We could just, for example, say console.log lat lon, and that'll print out our latitude and longitude. And we'll just say res.send to send no information down to the user for now. So now inside of here, we're actually going to make our API request. So if we go back down to our script, instead of calling our API directly here, instead what we want to do is call our server, which we just created. And this server is at http localhost 3001/weather. So we want to make a GET request to that URL, and we want to pass it some params. So we'll say params, and these parameters are just our latitude and our longitude, just like this. Let's just clean this up a little bit, make it a little bit more condensed, a little bit easier to read that way. There we go. So now let's just start up our server. We'll say npm run dev start. That starts up our server. Our client's already running, so if we refresh our client and inspect, we should see in our console, we're of course getting tons of errors. And again, we're getting CORS errors, it's saying being blocked by CORS, blah, 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 blah. We need to allow CORS to happen. So essentially the way to do that inside of Express is super simple. All we need to do is install a package, npm I, CORS is the package name. This will allow us to do CORS request, and all CORS is cross origin. So our URL here for our site is localhost 1234, and the URL for our server, if we go to it, is localhost 3001. These are two different URLs, and CORS just blocks any request to different URLs. But we want to be able to allow requests from different URLs. So we're going to essentially say, hey, you know what? We want to allow those requests, and by using CORS, we can do that. So we can say CORS equals require that CORS library, and we can just say app.use CORS and call it as a function. And this just says allow a request from any URL at all. It doesn't matter. So now when we save and rerun our server, we hopefully shouldn't get those CORS errors. So if we inspect, after we refresh our page, you can see we've no longer gotten any CORS errors at all. And you'll also notice on our server, we got that latitude and longitude value being printed out. So we've successfully passed a latitude and longitude value from our client here all the way over to our server. And again, the way this is working is in our script, we're just making an Axios call to the server we've created, passing it the latitude and longitude, and then inside of our server, we're just getting that from our query. Now, the next thing we need to do is obviously make those calls. And again, we're going to use Axios on the server. So we're just going to say npm I Axios. So that'll install it on our server, restart our server again, and we'll say const Axios equals require of Axios. There we go. So now instead of console logging this out, instead what I want to do is I want to say Axios. And what I want to do is I want to do a GET request, and I want to get that URL. So if we just come back here a little ways, we can actually get that URL. Let's just copy that. And we need to pass in some params to this. So we'll say params, and the params are going to be our latitude. We're going to have our longitude. Those are the first two things. We also need to have our app ID. That is going to be our API key, which we can just copy again. If we just go back to here, copy this API key. For now, we'll paste it in here hard-coded, but we're going to move this to a more secure location in a little bit. Now we just go back to here. We can include and exclude, which we're going to ignore for now, and we can include units. I already know that we want to do imperial units because everything is going to be in the imperial system. So we're just going to type in imperial here for our units. I'm American, so that's what we use. We're kind of dumb. We don't use the metric system. Anyway, that's all we need. So let's just save that. And then all we need to do is return this data to the user. So I'm just going to say .then, and this is going to take in our data, which we'll just destructure here from our request, our response, I'm sorry. And we can just say res.json of our data. And res.json just says send JSON data down to the user. So in our case, we're sending our JSON data to the user, but if we have an error, then we're going to send a different set of information down to the user. We can just say console.log our error, and then we're going to res.send status of 500. And if we send a status of 500, it essentially means, hey, we had an error. So if we have an error, we tell them we had an error. Otherwise, we send down the data we got from this API request. So now if we just refresh over here and we inspect, we go to our console, you can see all this data is being printed out. And that's just because in our script, we're logging out the data we're getting from our response. So if we go back in and inspect that, you can see we're getting our current data. This is like the current weather. We're getting our daily weather. We're getting our hourly weather. We're getting all of the minutely weather. And if there was any alerts going on at this time, as you can see over here, we're also would get alert data as well. In our use case, we don't care about the minute-to-minute weather and we don't care about alerts. So in that exclude section, we're just going to put both of those in there. So we can just say exclude, exclude, and we can just set this to minutely, and we can set it to alerts, just like that. Now, if we make that request again, and we go over to our console, you'll notice that we don't have that minute section, and we don't have that alert section if there are any alerts. Now, if, for example, this API is not working as expected or it's no longer available, instead, what you need to do is just come in here. You could say const weather data is equal to, and just require that JSON file that I've created, example.json. And now in place where we have data here, you just use weather data. So you can comment out this entire Axios code, and everything we write inside of this .then, you'll just put right here. So this is where you would put any code that ends up in this .then, because we're just already getting the data. We're not actually making any API request, if that makes sense. So only do this if, for example, this API is not working for you, it's down, it's broken, it's changed, whatever that case is, then you can do this weather data example JSON file I've created. Otherwise, continue following along because it'll give you a little bit better practice if you're able to use the API directly. So the first thing I want to do is get this API key out of my code and hidden away so no one can access it. So to do that, we're going to create a .env file. Make sure it's .env, just like that. And then we're just going to take this API key, and inside of our env, we're going to create a variable called API key and set it to that API key. Then inside of our server, instead of using it directly here, we'll just say process.env.api key. And this name API key is just the same thing as what we put inside of our env here. So if we put API key 2, this would be API key 2. It really just has to be the exact same name. That's all that matters. Then to load these environment variables, we're going to use a library called .env. And it's just dot spelled out env. Let's restart our server. And with this library, all you say is require .env, and it has a function called config. This was going to load all the information from our .env and put it in this process env variable so we can actually access them. So now with that done, we should have everything still working as before. So if we just refresh our page, we should still get our information being passed to us in the console. And as you can see, we do. So by doing this, we've hidden our API key in this .env. And if we're using something like Git, we could just set up a .gitignore that could have our .env file in it. That way we don't actually commit this .env file to Git. Also, we would put our node modules in here since we never want to commit our node modules to Git. And there we go. Now we have our .env completely hidden, so this API key is never accessible by anyone. It's never in the code. It's never in GitHub. No one can ever access this except for us, which is exactly what we want. Now, technically, what we've done on the server, it all works. And technically, this is all we need to do on the server. And we could do all the processing of this big array of data that we have here on the actual client. But instead of passing all this information to our client, I'd rather just parse it out and only send the information we want to the client. And so we can do all the parsing ahead of time. Because right now these are kind of annoying to work with. As you can see, like the variables use underscores instead of camel case. It's just not ideal. So if we can do all the parsing on our server, it'll make it easier to work with on the client side. So inside of our server, what we want to do is essentially parse this data. So we're going to do a res.json, and we're going to send down daily data. We're going to send down current data, and we're going to send down hourly data. And the very first thing that I want to work on is this current data. So we'll just create a parse current weather function, which takes in our data and it parses it. We're going to do the exact same thing for daily and hourly, but they're just going to be parse daily weather and parse hourly weather. And all these functions are going to do is take our data and convert it to a format which is much easier to use and only gives us the information we're actually using. So let's create those functions. We have parse current weather, which takes in our data. We have a function called parse daily weather, and we have a function called parse hourly weather. There we go. That's all of our functions. And also, just for these testing purposes, we're going to send down another property that's just our data itself. So we'll just say data like this. That way, when we do an inspection over here and we look at our console, we can see the data we want to pass, our current, daily, and hourly, and we can also see the data as a whole. So if I just do a refresh, you'll see we have data, which passes all of our data, and then we have nothing for the current daily or hourly section because right now they don't return anything. So data is just our original data, which we're going to remove eventually, but we can use it to look at and say, okay, instead of our current, what do we actually care about? So we can figure out what the names of everything are that we care about. So I'm actually just going to move this off to the side here. I'm going to move this up to the top here so we can kind of just see exactly what we need. And for now, I'm just going to minimize down this section on the sensors. So inside of our current weather, we have our current section open. We care about the actual current temperature. So if we look, there's a variable called temp inside of current. What we can do is destructure data to give us our current, which just gives us all of the information inside this current property. We can do another destructure, and we know that we want to get temp from current. So we know that we want to get our current temperature, and we want to get the description of that temperature here, as well as an icon to display. So if we keep going, there's this weather category, and this weather category is an array, and it contains a description and an icon. And this icon is this URL right here. So what we can do is get that weather information. So that takes care of our icon as well as our description. Then we want to get our high and low temperatures. And you'll notice in here, there's no information for high and low, which is kind of a bummer. Also, there's no information for feels like high and low, but we can get the wind because wind is right here. So we can get wind underscore speed, just like that. And then precipitation, again, is not available inside of this current section. So what we need to do is go to daily, and the very first day is going to be our current day. And in here, we have things such as precipitation, which is pop. We have things like the temperature, which has a maximum and a minimum value, and so on. So we can get all of the daily information we need right here. So let's also get daily. And inside of here, we're going to destructure some more values from daily. Inside of here, you'll notice that we need to get a section called pop. This gives us a percentage chance of precipitation. So we're going to get pop. We also want to get this temp category. So we're going to get temp. And I'm going to rename this temp variable up here to the current temp, just so we don't have any confliction between these two names. Also, on top of that, we need to get this feels like category so we can get the high and low in that section. So we can get feels like. And that right there should be everything that we need to get from that daily category to cover all of these different sections of our UI, because this top section is just our current weather. So now we just need to return that in JSON that makes sense. So we can just return this as an object, and let's just take our current temp here, and that's just going to be our current temp. And these numbers you'll notice are actually decimal numbers. So we're just going to round all these. So we're going to say math.round our current temperature. We also need to get our high and low temperature. So we can say high temp, and that's just math.round again, since these are rounded numbers or unrounded numbers. And in our temp, we have a max property we can get. So we can say temp.max. I can copy this exact same thing down to get our low temp, which is just our temp.min. Then we can get our feels like sections. So we can get our high feels like. And this high feels like is going to be a little bit trickier because in our feels like we don't actually have a high or low. So we need to manually calculate our high and low value. So we can say math.max, and we can just spread over all the values from that feels like. What this essentially is going to do is it's going to get the maximum one of these values, and then we just want to round that, so we can say math.round of that value. So we're just spreading through all of these different values, getting the maximum one and then rounding it. Same exact thing for our low feels like, but instead of getting the max, we want to, of course, get the min. So now we have our high, low for both of these. We need to get our wind next. So we can say wind speed is just equal to wind underscore speed. And of course, we want to round this. It just looks a little nicer in the UI. And then we need our precipitation. So our precip, which we'll abbreviate it to, is just rounding of our pop. And this pop comes in the form of a decimal. So we're just going to make sure we multiply this by 100 so we convert it to a percentage. So that takes care of this entire right side section. The last things we have are our description and our icon. So we can just say our icon is equal to weather. And if we go to that weather section in our current, you can see it's an array, and we want the first value from that array, and we want to get the icon. Then we need the description, which is just weather, first one again, dot description. So all we've done is we've essentially parsed all of this information and given just the parts of the data we care about in a format that makes the most sense. So when we go to actually put it in our UI, it's as easy as pretty much just pasting it in there, not having to worry about doing all these complicated permutations. And that's going to give us our current weather. So now if we save and refresh our page over here, it looks like we're getting an error. It says cannot read property max of undefined. If I look inside of here, Most likely this is because temp is not being properly propagated, and the reason for that is daily is an array, and we want the very first day. So we're just going to get the first day of our daily. That should hopefully fix this error. So now if we refresh, you'll notice we get no more errors, and now we have our current, which is the information we care about, and you'll see it's just so much easier to work with. It's not super complicated, it just gives us the exact data we need. And then data is again just everything, and that's purely for our debugging purposes. We're going to remove this once we get all of these other parse functions written. So now the next step is to parse our daily data. So if we look, we just need an icon, we need the date, and then we essentially need to get the weather. This is much simpler than what we did for our current weather. So in parse daily weather, we can destructure to just get each one of our days. What we want to do is just take our daily, and we want to just map over each one of our days. But we want to make sure we don't get the first day, because you'll notice we get 8 days returned, and the first day is the current day. And we only want to get the future day's forecast and not the current day's forecast. So to get every value in the array except for the first, we can say slice 1, and this just says get everything from the first index onward. So everything from 1 all the way down to the end of our array, and it just ignores the very first value in our daily array value. Then we can return an object. We're just going to convert these to a new object. And what we want to do is we want to get the date. In our case, this is stored as a timestamp, as you can see here, dt. And one interesting thing is this timestamp is actually stored in seconds instead of milliseconds. So we need to convert this to milliseconds in order to use it inside of JavaScript. So we'll say timestamp is just our day.dt times 1000. That converts it to the value we can use in JavaScript. Our icon comes from that weather section, just like before. So we can say day.weather of 0. .icon, and then our temp comes from here, and all I care about is the temperature during the day. So I can say temp is day.temp.daily temperature. There we go. So we have the daytime temperature, the icon, and the timestamp for our daily weather. And if I refresh, you can see now in our daily section, we have an array of 7 different values. Each one has the correct timestamp, it has the icon, and then of course it has the temperature at that turn time. And I want to make sure, again, I round that temperature so it's just a little bit easier to work with. So now if I refresh, and I look at one of our daily values temperatures, you can see it is now rounded. Now we're nearly done with the server-side section. The only section we have left is hourly. And hourly, I just want to get all of the times from the current hour all the way to the very end. Because if we look at our data section, in the hourly, it actually returns to its previous hours as well as future hours. And I only care about the hours that are either the current hour of our time or all the hours in the future. No other hours do I care about. So in our parse hourly weather, we can get this hourly information destructured out. And I want to do a similar thing to what we did in our daily weather. I just want to take our hourly, and I want to map over each one of our hours, and I want to convert them to a new value. But before I map over them, I want to make sure I filter these hours to only get the hours that I care about. So we can take the timestamp of our hour, and from the current section, if we just come in here, current has a timestamp. This is the exact current timestamp. We can actually say, I want to make sure that our hour timestamp is greater than our current timestamp, but since I want to also include the hour that we're currently in, I'm going to subtract out 3600, which is essentially the number of seconds in an hour. And to make that more clear, I'm going to create a variable called hour in seconds, which is equal to 3600, and we'll use that in this place here. So essentially all this filter is doing is it's saying, okay, take each hour, check their timestamp, and if their timestamp is greater than our current timestamp minus 1 hour, then we want to keep that time. And that'll give us every single hour, including the hour we're currently in and all the hours after it. Then I just want to take the hour and I want to convert it to a more easy to use format. So let's go to our hourly section, open one of these up, and we kind of have all of the same values. And if you notice here, we need to get our date. So we need to be able to have our timestamp returned to us. So we can just say here, timestamp, which we know is hour.dt times 1000 to convert it to milliseconds. We need to get our icon. We've done this many times before. That's just hour.weather of 0.icon. We also need to get our temperature. And this again is going to be our hour.temp. So we can just say temp is math.round of hour.temp, as you can see right here. Next, we need our feels like temperature. So you can see we have a feels like section. We can pretty much copy this exact thing down. We have feels like, and we need to set our feels like to that value. Then we have our wind, which is down here as wind speed. So we can say wind speed is equal to math.round of hour.wind speed. And then finally, we have our precipitation, which is just pop. So we can say that our precip is equal to math.round of our pop, which is just hour.pop times 100. And there we go. That is all the parsing we need to do. If we refresh, we should get here our current, daily, and our hourly information just as we want. Now the next step is just come up here. We can remove that data section since we no longer need it. And now we only have the current, daily, and hourly sections that we've parsed ourselves and formatted exactly like we want. So now all the data is available. We have all of the data on our client. The next step is just to actually put the information into the actual UI. So let's just come down here. First, let's set up a simple catch just to make sure in case we do have an error that we actually log this. We can just console.log our error, and we can say alert error getting weather. Please try again. Just a really simple error catcher for us. And now instead of logging out our data, I essentially want to render our weather. So we're going to create a function called render weather that's going to do that for us. And this is going to take in our data. In our case, that data is our current, our daily, and our hourly data. And I'm just going to create 3 more functions that allow us to do our rendering. So we're going to say render current weather, which takes in our current weather. Copy this down a few more times. We're going to have our daily weather, and we're going to have our hourly weather. And these are just going to take in daily, and this one's going to take in hourly. Again, these are just small little helper functions that make doing this code easier. Also, if you remember, in here we had this blurred class that we want to make sure that we apply. So if we just do a quick refresher, you can see now it's all blurred out. And whenever we get our information, what we want to do is we want to take our document.body, we want to take the class list, and we're going to remove that blurred class list. So while the information is loading, it'll be blurred out, and then as soon as it loads, we'll actually take away that blur. And these errors are just because our render current weather function is not defined. So let's just create those functions. We're going to create render current weather, which takes in current, and we're just going to copy this because we're going to have a render daily weather, render hourly weather, and they're taking in daily and hourly. That should hopefully get rid of these errors. And as you can see, it starts out blurred, and as soon as everything loads, the blur goes away. It happens really quickly because it's just local communication, but it still has that nice effect in case someone has a slow connection speed. So now, since we're keeping our page blurred out when we start, I don't actually want to remove all of our HTML. I want to keep all these placeholder values in, but I want to add the ability to change them to our new value. So the first thing is our image. We need to be able to change this. So this is our data current icon. And we're just going to look at everything dealing with current. Also, I want to change this here, which is our current temp. So I want to wrap it in a span so we can actually modify this value. And I'm going to give it a nice little data property, data current temp, so we can modify that. And then here, this is our description. So we'll say data current description, just like that. That's the 3 values on the left side here. The next side is this right-hand side. As you can see, we have our high value. And again, I want to wrap this in a span. Make sure I spell span correctly. Put that 23 in the middle there. And then this is going to be our data current high. And I'm pretty much just going to copy this down for our feels like high. So this is the value of 26 inside of here. This is our current feels like high. Then we have our wind down here. So I'm going to copy this span again, just so I don't have to type it all out manually. Give it the value of 12 inside of here. And this is our current wind. Then down here, we have our low. So I'm going to, again, just copy the span to make my life easier. Put the value of 12 in there. And this is our current low. Again, right here, this is going to have a value of 13. And it's our current feels like low. And then finally, we have our precipitation, which again needs to be in a span. It's our current precip. And this has a value of 14. So if we save, we shouldn't see any change at all over here, and we don't, so that's exactly what we want. But now we have abilities to access all of these different property values so that we can change the actual content of them to the exact content we want. So inside of our script, in our render current weather, we can actually do that. So I can come in here and say document.query selector, and I want a query selector, let's say our data current temp, and I just want to set the text content equal to our current.temp. And now, of course, that didn't actually do anything because our current.temp must not be set properly. And that's because I called this current temp instead of just temp. And now, as you can see, it's properly putting the value 48, which is whatever is in this current.currentTemp variable. Now we essentially just need to copy this down a bunch of times. So I'm going to copy this. We need to do this for our current high, and this will be for our current high, just like that. And now our high value should be set. Looks like I actually just called this high temp though. And there we go, that sets the actual high value. And you'll notice that we're going to have the same repeating pattern where we do a query selector, set the text content to a specific value. So I'm going to create a function that just does that for me. It's going to be called setValue. It's going to take in a selector, and it's going to take in a value, and it's going to set that. So we're going to say document.query selector. And we already know that we're going to do a data/query selector. Then we're going to put our selector in here. Make sure I do it in the correct brackets there. And then I want to take the text content and set it equal to our value. And that should go outside the parentheses here. So essentially, I'm just taking this code and I'm simplifying it. So now we can call setValue, pass it in current temp, and pass it in our current temp, and that'll do the exact same thing. And if I save, you can see again, it sets our current temp. If I copy that down, we can now change our current high to be set to our high temp, get rid of this, and again, see exact same thing. So this is just a much easier set of code to work with. So I'm going to copy this down quite a few times. We're going to have to change our low. We're going to have to change our feels like high. We're going to have to change our feels like low. We're going to have to change our wind. We're going to have to change our precipitation, which is just precip. And then finally, we're going to have to change our description. Just like that. So now if we just come in here, we can get our low temp. We can get our high feels like. We can get our low feels like. Our wind speed. Our precip. And then finally, our description. And now if we save, you can see all of this information over here has been properly propagated based on what we're getting from our server, which is exactly what we want. The last thing we have left is our icon, which unfortunately requires us to do some custom code because we can't just set the text content. So we're going to say const current icon is equal to document.query selector. And we want to get this from data current icon. And essentially all we want to do is we just want to take our current icon. We're going to take the source. We're going to set it to a specific source. And if we look in here, you're going to notice that we have this URL that we can use for our source. And if let me just paste this down so we can see it, it's just http openweathermap.org/image/wn. Then we have the icon code, which is 10D. In our case, that's just current.icon essentially. And then at 2x, this means it should be 2 times the normal size. So what we need to do is specify essentially 2 different URLs, one for the 2 times size and one for these normal icons, which is just the normal size, not 2 times. So I'm going to create another helper function. This helper function is just going to be called getIconURL. It's going to take in the name of our icon, and it's going to take in an option for large, which we're going to default to false, and we'll default that option to an empty object. Then what we're going to do is we're going to say that the size is equal to here large. So if we have a large one, we're going to get the at 2x. Otherwise, it's just going to be set to an empty string. And then we can get this URL down here. So we can say return this URL. And what we want to do is replace this section with our icon. And we want to replace this at 2x section with our size. So by default, it'll do just a normal size, nothing. Otherwise, if we pass in large, it'll return this at 2x size. So now we can set this here equal to getIconURL with our current.icon and large set to true. Now if we save this, you're going to notice this icon is changed up here to the current icon, which is broken cloud icon. Now the next section we have to work on is going to be our daily section. So let me just expand this down. You can see the daily section just has all of our daily cards. So we're going to use templates to make this a little bit easier. So what we can do is just take one of these daily cards. I'm just going to copy it and I'm going to convert it down to a template. So I'm going to scroll all the way down to the bottom here. At the bottom, we can create a template. We're just going to give it here an ID, which is just going to be equal to, let's say, day card template. And in here, we'll just paste in our day card. And we just need to add different selectors. So we're going to have our data date. We're going to have our data icon. And then finally, let's create a span for this. This span is going to have a data temp. And let's put that value inside of that span. Now we can actually use that template inside of our code. And also, we just scroll up all the way again. We need to be able to make sure we can access this section, which has all of our daily stuff in it. So we're just going to give it a data day section attribute so we can select this inside of our code. So now what we can do is create our daily weather render function. First thing we need to do is get that day section. So we'll say daily section is equal to document.query selector. And we want to get that data day section. And also we need to get that template. So this is just our day card template, which is equal to document.getElementById, since we gave it an ID. Let's just double check what that ID is. And that ID is day card template. We'll just copy that over. Just like that. So now we have our template and our daily section. First thing we need to do is just take our daily section and clear it out. Inner HTML equal to an empty string. And it's okay to use inner HTML in this case because we're just passing in an empty string. There's no user values, there's nothing to worry about. It's just an empty string, so this is perfectly secure. Then we can take each of our days, and we just say for each one of our days, we want to loop through it, and we want to create a new card. So const element is equal to our day card template. We want to get the content from it, content, and we want to clone that with true being passed in. Then I can just use that set value function we had before. I want to set our temp. I want to set it to our day.temp. But you'll notice, let me make sure I get my parentheses correct here, day.temp. You'll notice though, in our set value function, we're always using the document query selector. And in our case, we want to use this element as our query selector. So what we can do instead is just pass in a third parameter called parent. And this parent will be our element. And then inside of set value, we'll take that third parameter of parent. We're going to default it to our document. And then also make sure we default this to an empty object in case we don't pass a third parameter. And then we can use the parent here. So if we don't pass a parent, it'll use the document by default. Otherwise, if we do use a parent, such as down here where we pass an element, it'll use that for the actual parent. And let's just make sure that this here is set to an equal sign. So it's going to default this parent to document. So now if I save, nothing at all has changed. Our day cards have cleared out because we've cleared them out. But now we've actually set the value of our temp based on this set value using this parent of element. And we can do the exact same thing for our date. We can say set value of date. And this is just going to get our data date. And we can just say day.timestamp for now. We're going to convert this to an actual date later, but for now we'll just render it out as the timestamp. And the parent here is going to be set to our element. Then what we want to do is just get the query selector for our icon. So we can say element.query selector of data icon. Get the source of that. We want to set it to get icon URL for our day.icon, since we want the smaller icon here. And then finally, we can add this to our daily section by appending that element. So now if we save, you can see we have our icons showing up, we have the temperature showing up, and we have the timestamp showing up. But of course, it's not really well formatted. We want to format this as an actual date. In order to do this formatting, we're going to be using a library called datefns, and this library has an awesome function called format, which allows you to just pass a bunch of different string parameters and it'll allow you to do some crazy formats. As you can see, there's tons and tons of different options. If we scroll down to some of these examples, you can see that if we say, okay, you know what, we want to format this date with the triple M, it'll give us the name Nov. Or if we do 4 M's, it'll give us the full name November. So we can kind of really fine tune exactly how we want to format everything. So we want to install this datefns. If we go to our server, npm I, or on our client, I'm sorry, datefns, we install that library super quick. And way up at the top here, we can import that format function from datefns. So now we can actually format our dates. And I'm just going to create a simple helper function to do this for us. I'm going to call this format day. This is going to take in a timestamp, and all it's going to do is return to us a new date from that timestamp. And we want to format this, so we're going to call format on this. And what I want to do is just get the day. So if I come here and I search for the section that includes just the day values, you'll see right here, local day of week. And if I pass it 4 E's, it'll give us the full name here. So I can just get this section with the 4 E's, pass that in as my format string. And now if I call format day up where I'm rendering out my daily values right here, if I call format day with that timestamp, it should return to me just the string of the name. So if I refresh and make sure I actually run my server again since I stopped it. So now it should, once it builds, refresh itself. And then I should hopefully see the names Monday, Tuesday, Wednesday, Thursday, and so on being printed out in that days section. And of course, it's taking a little bit of time to build, but as soon as that finishes, you can see we get the next 7 days of our forecast. And I'm recording this on Monday, so the next day is Tuesday, which is why Tuesday is the first value being printed out here. And it goes all the way until next Monday. Now, the last section we have to do is this hourly section. And honestly, it's going to be almost exactly the same as daily. They are very, very similar. We just need to first get some variables here. So we're going to say const hourly section is equal to document.query selector. And we're going to get a section called data hour section, just like we did in the daily section. Let's make sure I spelled this correctly. Then we're also going to get an hour row template. And we're going to do this with get element by ID. And this ID is very simply just going to be our row template. And then we can do all the same code we did inside of here. We can clear out our hourly section by setting inner HTML equal to an empty string. We can loop through our hourly. So we can say hourly dot for each hour. We want to create a new element, which is coming from our hour row template dot content dot clone node true. And then at the very end, we're going to take our hourly section and we're going to append in that element. And of course, in between these sections, we're going to do a lot of code by actually putting the values into this different row. But first, let's get all of our query selector stuff set up. So in our index.html, of course, we're getting an error just because we don't have these set up yet. In our table, in our t-body, we have all of the rows for our hour section. So in here, we can say data hour section. This is where we want to add our new rows. And then we're going to copy one of these rows, which is actually pretty lengthy. So I'm just going to copy this whole thing here. We're going to put that into a template. So we can say template, which has an ID, which is our row template. Make sure I spell template correctly up here. And now what we can do is actually put all of our data attributes inside of this section. So first thing first, we have our data day right here. We have our time down here. We can say data time. Here's our icon. So let's just call this a data icon. Then we need to wrap this in a span, and we're going to call it data temp because it's just our temperature. We're going to copy this span down because we're going to do this a bunch of times. On our feels like, we're going to make sure that this has a data fl temp. Our wind right here, we're just going to make sure it says data wind. And our precipitation, same exact thing, is going to be data precip. So we'll just say data precip. Those are all of our data attributes that we need to be able to select these inside of our JavaScript from the HTML. So now let's just do that. We can say set value, and we can call it for our temperature is the first thing that we want to set our value of from our hour.temp. And again, we need to make sure that our parent is the element. So we do that. We now should have our temp set. And as you can see in these rows, it is setting the temp properly. Obviously, none of the other stuff is being set, but you can see the temp is changing with each hour, which is exactly what we want. Next thing we need to do is the feels like temp. I'm just going to copy this down. We have fl-temp. That's going to be the same as our hour feels like. Then we're going to have our wind, which is going to be our hour wind speed. Copy that down for our precipitation. That's just coming from our precip. Copy that again for our day. And this is coming from our timestamp. And then we're going to need to get our hour, or I'm sorry, our time, which is again coming from our timestamp. We're going to create formatters for these in just a little bit. And then finally, we of course have our icon. So I'm just going to copy this exact code up here for our icon. And of course, let's make sure that we actually specify our data selector correctly in both of these. And it's just going to be our hour.icon. And that should be everything we need other than getting these timestamps working. So if I save this, you can see it's printing out our timestamps. We get our icon, we get our temperature, our feels like, our wind, and our precipitation all propagating exactly as we want. So the next step is just going to be for our formatters. Our day, we already have a formatter for. We can just say format day, pass it in our timestamp, and all of a sudden our days are correctly formatted. All we need to do is do a formatter for our time. And let's just create that function way up here. Function format time, which takes in a timestamp. And it's going to do a very similar thing. It's going to call our format function with a new day, or I'm sorry, a new date, which takes in our timestamp. And then we need to pass it in our string. So if we look over here where we can actually get different values, you can say we get AM, PM by using A. And if we want to get the actual hour, we can just kind of scroll around till we see that I was right here. We use a lowercase h and it's going to give us the hour. So if we put H followed by A, this is going to give us the hour followed by AM or PM. So now we come over here, you can see Monday 3 p.m., Monday 4 p.m., Monday 5 p.m., and so on. It's giving us all the hours in the future. and all the values associated. As you can see, we have temperature, feels like temp, wind, and precipitation. So an entire weather app has all of our data being perfectly pulled from the API, and most importantly, is it's calling our server to get that information, which means our API key is completely hidden from anyone's information. And that's all there is to creating this simple weather app. There's tons of things you can do to expand upon this weather app by allowing users to choose specific locations and so on, but I leave that more as an exercise to you to expand upon this in your own ways, because I think there's a lot of cool things you could do to this. Now, in the next section of the course, we're going to be talking all about clean code and how you can write more maintainable code, more clean code, and use different structures in your code. It's a really fun section, and I can't wait to see you there.